Welcome to my channel. I'm Zhang Jingxu. Let's look at the problem 58 in chapter 5. So first the situation is if a curve with radius 85 meters is properly banked for a car traveling 65 km per hour. So in this one we think the velocity v1 is 65 km per hour. What means the properly banked for a car traveling? That means no friction, right? The car just perfectly do the circular motion due to the central force. So in this one, we do the first, and then the second one tell you, in the second cases, we need to consider the static friction for a car, not just a sliver, but traveling at the V2. So this is situation. This one is perfectly banked for the car traveling. This one we consider the friction. So in this one, first one we consider the gravity, right? Second one we have normal force. So we can project the normal force has F1 sin theta and F1 cosine theta. So this is perfectly banked travel. The second one, so in this one we can see we have the y component F1 cosine theta minus gravity equals 0 because the car didn't move at the y component. So at the x component we have the F1 equal to sin theta. This is a central force equals mass times velocity divided by r. Therefore, we can get this angle theta. Tangent theta equal to v1 squared divided by gr. In this way, you can find the angle theta. And this part is we learned in the textbook's examples. So second one, we need to consider the static friction, right? So for static friction, first one we can say we need to consider gravity, normal force, and then project the normal force in x component and the y component, F1 sin theta, F1 cosine theta. Also, we need to consider what? Friction. In this case, friction moving down, right? Friction moving down, so we project it in two components, sin theta and then cosine theta. In this one, we can write the equations. So first one, F1 cosine theta minus the gravity minus this friction sin theta equals 0 because there is no motion at the y component. And then we look at the x component. We have the F1 sin theta plus the friction times cosine theta equals mass times the central acceleration. This is central acceleration v squared divided by r. This way becomes a v2, 95 km per hour, right? And then how can we decide this friction is mu s times the normal force? Therefore, you can see angle theta is given from the part 1, and then the velocity v2 is given, and then the radius is given. So it's very easy to get the friction, and then you can get the mu s. After you input the numbers inside, you can find this mu s just 0.33. Thank you.